In today's lecture, we are going to study chapter 8, which is dedicated for compaction and settlement. Before that, we studied slope stability. This was chapter 7. And of course, before the slope stability, it was the shear strength and the shear box testing and total and effective stress, soil water and site investigation and soil classification. All of these subjects were studied. For the compaction and settlement, we have to think of two things. We have many types of soil. We have two major groups of these types: cohesive and cohesionless. Cohesive, similar to the clay, cohesive. Cohesionless, similar to the sand. So, sand has different characteristics than clay. What is this difference? In sand, I have a friction angle, but I have C equal to 0 in pure sand. In pure clay, I have the opposite. I have C equal to value and phi equal to 0. So of course, if I have these two major differences, then I expect that the behavior of these two will be different. If sand is subjected to load and clay is subjected to load, there will be a difference in the behavior of both. What is the difference? The difference is mainly related to water. Because in sand, I have very high permeability. And you have studied total and effective stress, and we said that we are targeting the effective stress. We don't care for the total stress, because the total stress means that part of the load is carried by the water, and this part sooner or later will be dissipated and will return back again to the soil. So I need to study the effective. What does the soil carry? What is the portion of the soil? I don't care for the amount carried by the water. So, in sand, the permeability is very high. Permeability is very high. It means that when you subject the soil to load, it means that the soil will carry and the water will carry. But the water will quickly run away. So once it runs away, immediately, it will not take any time. Immediately, when you put the load, the water will be expelled outside. So it means that the soil is carrying everything, and the effective stress in this case will be equal to the applied stress, and it will induce settlement in the soil, and this settlement will be instantaneously. It will happen on the spot. Clay is a little bit different, because clay has very, very low permeability. So when you subject the clay to load, it means that small part of the settlement will happen immediately, but still the water carries a portion of the load. So it means with time, water will be expelled outside, and the load will be transferred to the soil, and the soil will start to settle again. So it means that in cohesive soil like clay, I will have settlement, but it will take longer time. It will not be immediate settlement. So it means that I have two different types of settlement: immediate settlement with sand, and long-term settlement with clay. This is what we are going to study in this lecture and in the next lecture. In this lecture, we are going to study something called compaction and settlement. Mainly, compaction and settlement happens immediately. Once I compact the soil, it settles immediately. But in chapter 9, we are going to study something called consolidation. Consolidation is the postponed settlement due to the effect of the low permeability of the clay. So now we are just concentrating on soil that has no problem in seepage. It can, the load will be carried directly by the soil, so it will settle, and I will need to calculate this amount. What is settlement of soil? Of course, if I have any building and this building is resting on footings, the soil beneath this building may be uniform and may be variable. Maybe below this foundation I have something, and below the other one I have another thing, and below the third one I have something else, and so on. Maybe the same layers but different thicknesses, or maybe different layers. It depends on what I face. What will happen is that each footing will behave alone. If this footing is resting on good soil, the settlement will be small. If this footing is resting on weak soil, the settlement will be high, and so on for the rest of the footings. So it means that my building may be damaged because of what we call differential settlement. Differential settlement means settlement of one footing different to the other one next to it, different to the third one next to it, and so on. So it means that my building will be cracked and damaged because of this variable amount of settlements. An example of a building that was affected by settlement is the Pisa Tower. The Pisa Tower, it was affected by the settlement, by the load of the tower, but actually those who studied this building or this tower said that, or published data saying that it is not just any type of settlement, it's a consolidation settlement. Consolidation similar to the one that we are going to study in the next lecture. It means that below this bridge there were layers of clay, or a layer of clay with variable thickness. So the settlement at one side of the building was huge, and at the other side it was less. So the building or the tower started to tilt. It started to tilt because of variable amount of settlement. Here they say settlement can occur almost immediately after a load is applied, or take years. When it will happen immediately, in what type of soil? From what I said now, to have immediate settlement. What type of soil will have immediate settlement, or you expect to have immediate settlement? Sand or clay? Sand. Sand. Why? Because the permeability of sand is very high, and water will go away quickly and it will settle immediately. But in clay, similar to this tower, by the way, this tower did not start to tilt except after few months of construction. Yani it did not start to tilt from day one. No, they started to build, they put load, one layer, and then it started to tilt. Okay, what? So it depends on the type of the soil, whether it is immediate or long-term settlement. Geotechnical engineers can often carry out settlement analysis prior to construction to analyze the ground condition and recommend foundation solutions for preventing settlement in the future. So it means that we design any structure prior to construction, and we estimate the amount of settlement that is expected to happen to this structure. We have three components for the settlement. What are these three components? Immediate settlement, similar to what I said this at least 2 or 3 times today. What is the example of immediate settlement that may happen beneath any structure? Where does this happen? In which type of soil? Immediate. Sand. This is correct. So immediate settlement, the example of immediate settlement is the settlement on sand. It happens. Of course, there are immediate settlements in all types, but in sand, the immediate settlement is maybe 99% of the total settlement, or maybe 100% of the total settlement. So immediate settlement, it means that they call it elastic settlement because it is still within the elastic zone. It happens very quickly, and it mainly happens in sand. Primary consolidation settlement, this is number 2. Creep settlement or secondary consolidation settlement. Let's first say that this is immediate settlement. Number 2 is consolidation settlement. What is consolidation settlement? The example of the consolidation settlement we said is for which type of soil? The opposite this time. Clay. So consolidation settlement, it happens with clay. Why it happens with clay? Because clay has a very low permeability and the settlement will be delayed a little bit. This little bit may be days and it may be months and it may be years. Some buildings would stay something like 70 years in consolidation period. It happens. So this is what we call consolidation settlement, or they later called it primary consolidation settlement because they discovered that consolidation itself happens in 2 stages. A primary stage, this primary stage may take, as I said, 70 years, but still this is the primary stage of consolidation. But we have another stage of consolidation, it is called the creep stage. From the name creep, what is creep? Creep, when I creep, when I sit on the ground and I creep, بزحف. So this is in Arabic, بزحف. It means that when you creep, it means that you are moving slowly and trying to adjust your position. So in some cases, there is something called a secondary consolidation settlement, and this secondary consolidation is sometimes called creep settlement. It happens at a later stage, but the amount of it is very, very small compared to the immediate settlement and compared to the consolidation settlement. That's why the creep settlement is less important because its amount is a little bit small. So the difference between number 1 and number 2 is in the time. Here, number 1 happens very, very quickly, it's immediate, and number 2 happens at a later stage and it may reach years. But the difference between number 3 and number 2 is not in the timing as much it is in the amount. The creep settlement is the amount of the creep settlement compared to the immediate settlement or compared to the consolidation settlement, it is a small portion. That's why sometimes they ignore it in the design, and sometimes they take it into the design in case you want to be very accurate and the loads are very high and the structure is very sensitive to settlements, so you have to calculate it. So this is our equation. ST, which is the total settlement, is equal to SC, which is the C, it means consolidation. So it is SC means consolidation settlement. Here is SS, it is the secondary consolidation settlement, and SE is the elastic settlement. Here it may be called creep also, but because we use C for consolidation, we cannot use it again for creep, so we use SS, it means the secondary consolidation, which is the creep. We'll study H, immediate settlement. By the way, primary consolidation settlement and secondary consolidation settlement, they will be studied in next lecture, because next lecture is dedicated for consolidation. But now we are going to concentrate on the elastic settlement or the immediate settlement. So immediate settlements, which is caused by the elastic deformation of the soil. Dry, wet, or saturated, it's not important. Here water is not important. Why it is not important? Because we said that the permeability is very high. So whether you have water or you don't have water, if you have water, it will be expelled. If you don't have water, then you have voids, and the settlement will happen. So it's not an important issue. Is it dry or wet? When the load is applied, stresses in the soil change. The soil particles are rearranged, causing reduction in void space. This is the definition of settlement. Settlement is the change in the void, the space allocated for the voids, decrease of this space, causing settlement. Why will it decrease? Because of the load. So the load causes stresses. The stresses decreases the voids between the particles, so it settles. Consolidation settlement, this is, as we said, it's another approach. It is the change of the amount of the voids also, but not because of this, but because water is expelled outside, because these voids are not full of air, it is full of water. So if you try to compress it, it will not be compressed. Water is not compressible. You cannot compress water. If you take any volume of water, try to compress it, it will not be compressed. It needs enormous amount to be compressed. You cannot compress water. But if you have air, you can compress air. If you have a bowl that is full of water, try to compress it, it will not be compressed. But if it is full of air and it will be compressed. So consolidation settlement, it's a volume change due to the change of the amount of water inside the voids, but this will take a long time to happen. A creep settlement, which is the third type here, we said that we have number 3 is the creep settlement. Creep settlement is the rearrangement of the particles itself. It means that regardless of the voids and these particles may be a little bit swayed, turned, or whatever to fit in a smaller volume. If I have few particles together, if I rearrange the particles, they will fit better in the volume that they are there, so the volume will decrease. So this is the definition of the creep. So once consolidation settlement is completed, because before consolidation the water is carrying load. So once consolidation settlement happens, then particles are close to each other. They start to touch each other again. So once they touch each other again, they start to modify the shape of the sides so that the particles would be rearranged to fit into a smaller volume. So creep settlements begins after the end of the consolidation. This component of soil settlement continues over a long period of time due to the constant pressure of the load. The amount of creep settlement varies depending on the soil type and isotropy, as well as the stress history and the stress level in the ground. So it depends on many factors, but in most cases, creep is the amount of creep is small compared to the total compared to the immediate settlement or compared to the consolidation settlement. So it depends on the accuracy of your solution of any problem. Do you want to consider the creep settlement or not? Type of settlement in soil. So this is the origin of the settlement, from where this settlement will happen. Is it immediate, consolidation, or creep? But there is another type of definition for the type of settlements, but in terms of the structure itself. Here we were speaking about the soil. How will the soil behave? But now we are speaking about the effect on the structure. Will the structure settle uniformly below, or will it tilt, similar to the Pisa Tower, or will it crack because of variable deformations? So this is another type of or another method for categorizing the settlement, but in terms of its effect on the structure. Here, below here, maybe immediate settlement, creep settlement, consolidation settlement, I don't care. But the combined effect of all of these settlements, it happened that the structure settled in as a one body, so it is called a uniform settlement. Also here, regardless of the type of the settlement below in the soil, I don't care, but what happened to the structure? It's a tilt, so it is a tipping settlement or a tilting settlement. And the third one, if it is variable from one place to the other, so it is called differential settlement with cracks. Here's what we just said. What is the difference between uniform settlement, differential settlement, and curvature settlement? This is a combination of many types of settlement because of different types of settlement in one building. So this building will be affected and it may be destroyed because of this settlement. Elastic settlement. I want to calculate, we said that there is something called immediate or elastic settlement. I want to calculate this amount of settlement. This amount of settlement depends on two main things. It depends on the type of the footing and depends on the type of the soil. What is the difference in the type of the footing? Do I have a flexible footing or a rigid footing? If you are standing on soft soil and I give you maybe a piece of plastic to stand on top of it, this piece of plastic will bend below you and it will be affected. It will be affected by the soil and it will affect the soil, but your load will be concentrated at the middle of this plastic raft where you are standing, and at the edges you may not have the same effect. But if I give you, instead of this plastic piece, steel piece or a concrete piece, it will be rigid, and when you stand on top of it, all of the soil below this piece will be compressed because it is rigid. So depending on the type of the footing, the behavior of the footing will be different. Here, cohesive soil on flexible footing. Here, granular soil, sand, it means sand, on flexible footing. So this, the case above here, this is the case of a flexible footing. It means that the footing can bend. You see here, this is the footing. It bended like this or it bended like this. It bended in the two cases, so it is flexible. But how will it bend depend on the type of the soil. If it is clay, cohesive soil, then this is the concentration will be at the middle, and at the edges it will be the bending will be less. And the opposite in case of sand. What about having a rigid footing? As you see here, in a rigid footing, here the footing is curved, here the footing is curved, but here the footing is straight, and here the footing is straight. So it is a rigid footing on cohesive soil like clay, or on granular soil like sand. This is the expected soil reaction beneath this rigid and beneath this flexible footings. Elastic settlement in case of a finite layer. So now this is the case of the elastic settlement in case of rigid or flexible footing, and in case of soil that is clay or soil that is sand or cohesive and cohesionless. This ends the introduction to the issue of the settlement. Later we are going to study elastic settlement in details till the end of this lecture, and of course consolidation settlement in the next the coming lecture. So we can conclude this introduction at this point and continue next time. Thank you.